Hello. This will be part two of A-level math pure and pure one math, and we are solving equations by factorization. Okay, so let's continue off to example seven. Example seven says, in example seven, there's A through F part, and the direction specifically says to solve. So on letter A, we got to solve this rational function. We have x minus 6 over x minus 5 equals to 0 or 0 over 1. So the first thing I'm going to do is, what can I do? So we have more than two parts. We have this side, the middle part, and then the further right part. So if you have more than two parts, you would have to get rid of the fraction first by finding the LCD, multiplying all three sides by the LCD. Okay. So the LCD is a bit difficult, can be a little bit difficult to find at first, but here's the trick. What you do is look at your denominator. So we have a 1, and then you have an x minus 5. That's like one base, and then you have a 1. And they are in the most premise form, meaning they cannot be broken down, right? So that's good. So if it's not if it's not in your most premise form, you got to break it down or make a factory. But because it's in the most premise form, we don't have to worry about that. All you got to do is look at the base. If you have a repeating base, which we do have a repeating base of 1, right? So if you have a repeating base, pick the one with the highest power. Since they're both 1 to the 1, right? 1 to the 1. You just bring it's just going to be 1, and then this is actually one single thing. It's a Yeah, you could think of this as one term, not two terms, but it's really x to the minus 5 to the power of 1, and it's a non-repeating base, so just bring it down. Okay, so if you have a repeating base, you pick the one with the highest power. If you have a non-repeating base, just bring it down. So this is our LCD. It's 1 times x minus 5, or really it's the same thing as x minus 5, right? Okay, so what I'm going to do is multiply all three sides by x minus 5, and let's see what happens. So over here, x minus 5 times x, nothing disappears, so just write it out. Just write it out now, you don't have to FOIL it out. So it's x times x minus 5. We here, be careful, there is a minus, so put a minus, and then I'm going to put a little bracket because you're going to distribute that minus. Okay, so what is x minus 5 times 6 over x minus 5? That looks a bit confusing, but if you get lost, write it out. What is x minus 5 times 6 over x minus 5? The trick is, if they're the same on the top and bottom, which we do, we have an x minus 5 that's the same, top and bottom, so they disappear, and then you're just left with the numerator 6. Okay, equals. And then what is this? Is simple. What is 0 times x minus 5? It's just 0, right? Okay, now let's clean this up. So FOIL this out. X times x is x squared. X times negative 5 is negative 5x. And then you have a minus, you have a 6, but you have a minus, so it's going to be minus 6 equals 0. Okay, now we got to factor and solve, right? So I'm going to factor this out, write out my two parentheses. This is pretty simple. It's simple factoring. So you're going to put an x here, x there, blank space, blank space. So this can be a little bit tricky. Um, can you come up with two numbers that multiply -6 and one out it gives you -5? So my immediate thought would be has to be somewhere between 6 and 1, because that's the only way it'll give you -5. And I think I'm going to use -6. So this, it can be a little bit tricky because it's a little bit of trial and guess, right? So let's see if this really works. -6 times 1 is -6. So yes, that multiplies -6. And then what's -6 plus 1? -5. Perfect. So we'll definitely use -6 and +1. Okay, but just because we got to solve for it, so what's my actual solution? It is +6, and -1. I can do this in my head because it's simple, but what we're really doing is you're setting each parentheses to 0 and solving for x. That's what you're really doing. So yeah, so sometimes it'll be super simple where you could just do it in your head. Sometimes you might have to like write it out because it can be complex. Okay, now this is also very important. You also have to be careful. You have two solutions. We have 6 and 1. You have to be careful about extraneous solutions. Extraneous. Just because you have two possible solutions doesn't mean they both work. So this is where you got to check it. In the other videos, in the other lecture, I didn't really check it. I didn't explain that you should check it because I already checked the work, but you should always check it for extraneous solutions. So let's test how do you check your work? You're gonna plug in your values. We have two. Let's plug in the x value 6, and then you're gonna plug it back into your original equation. So what that means is wherever you see an x, plug in 6. Plug 6 over 1 minus 6 over 6 minus 5 equals 0. 6 over 1 is 6, minus 6, and then 6 minus 5 is 1, so it's 6 minus 6, and then 0 equals 0. Is this a true statement? Yes, it is. Okay, now, so we could definitely use 6. And then let's test -1, so go ahead and plug in -1 back to your original. So basically, wherever you see an x, plug in -1. So plug it back here. So -1 minus 6 over -1 minus 5 equals 0. So it's -1 minus -1 minus 5 is -6. 6 divided by -6 is -1. And then over here, two negatives becomes a positive. So 1 plus -1 is 0. Is this a true statement? Yes. 0 does equal to 0. So this is why both solution works. So yes, so this is, you must always check for extraneous solution. Now, when I do the other examples, because I already done the work and I already checked it, I'm not gonna always check. I'm not gonna I'm not gonna always check it because it does take a lot of time. But when you're doing your work, your homework, always check for extraneous. Okay, so that is how you check it and both solution works. Okay, let's do letter B. It still says we gotta solve, so we have three sides, so we gotta get rid of the denominator by multiplying all three sides by the LCD. So look at your bottom. We have an x. We have a this. You could think of this as one turn, x plus 2, and then you have a 1, right? So ask yourself, do we have a repeating base? No, we have a base of x, and then x plus 2 and a 1. None of them are repeating. Well, are they in the most primest form? Yes, they can't be broken down. So what you got to do is, because none of them are repeating and they're in the most primest form, just bring it all down. So our base is going to be x parentheses x plus 2, and then don't forget about this invisible 1. So really, it's just x parentheses x plus 2. Now do not FOIL it out. Leave it as it is, and you'll see why. So now we're going to multiply all three sides by x parentheses x plus 2. Okay. So do it on all three sides. So let's start with the further left. What is this times this? So a bit that can be a bit confusing, but if it confuses you, just write it out. X times x plus 2 times 2 over x. The trick is if there's the same on the top and bottom, cancel. So I see an x top and an x on the bottom, so they disappear. So now you're left with 2 times x plus 2, right? Okay, continue the middle part. What is this? X times x plus 2 times 3 over x plus 2. So just write it out. If it confuses you, look, what do you see? That's the same top and bottom, the x plus 2. right? This is like one whole term. So this disappears. So now you're left with, don't you have a plus sign, so it's gonna be plus. You're left with 3 and x. Okay, does that make sense? Okay, and then on the further right, what's 1 times x was 2? It is just itself, so I'm just gonna write it out. Okay, uh, let's continue solving. So we got to do some foiling and factoring. So let's do the right side. So what's x times x? X squared. What's x times 2? 2x. And then on the left, FOIL this out. So this is going to be 2x plus 4 plus 3x. Okay, let's see here. Before I move things around, maybe I think I should get everything to the right. Before I move things around, can you collect like terms? So on the left, you have a 2x and a 3x. Yes, you can. That simplifies as 5x. It's 2x. And then I think it's wise to just move everything to the right because this has an x squared. I don't recommend moving this to the left. I mean, you could, but it's just more work. So I'm going to move everything to the right. So I'm going to subtract 5x, subtract 4. Get 0 equals x squared. And then what is 2x minus 5x? Negative 3x. That's 4. And then factor this out. So this is going to be x, blank space. And then this is the tricky part. What two numbers multiply negative 4 and added gives you negative 3? Maybe 4 and 1. And maybe I'll make 4 negative, right? So let's see. So negative 4 times 1 is negative 4. Negative 4 plus 1 is negative 3. Perfect. And so check mark. It's going to be negative 4 and positive 1. Okay. Um, Now you got to solve for it. So what is my actual solution? My actual solution is positive 4 and negative 1. Okay, I already tested these. I already checked my work in the back of the book, and they are the solution. But I forgot to keynote. There is one clue that it will not work. If it somehow makes, let's for example, um, let's say you had an 1 over x minus 1, and one of your solution was positive 1. If you plug this back in, this is how you know it doesn't really work. If you plug in back here, this would be 1 minus 1, which is 1 over 0. You have a 0 on the bottom. That's a big clue that that is an extraneous solution and that will not work because 1 over 0 is always undefined. Okay? But I tested each one and it doesn't make the bottom 0. It makes this, and each one makes a statement true. So both works. Okay, let's do letter C. So definitely we got 3 sides, left, middle, and right, and we got to get rid of the fraction. So we're going to multiply all 3 sides by the LCD. So this one's a little bit different because on the bottom they were dealing with letters and numbers, but this one we're just dealing with numbers. So here we have a 4, a 2, and a 1. Now I know what you're thinking. None of them are repeating base, but are you always got to check if they're in the most fact primest form. So 4 is not prime, right? 4 can be broken down. What I mean by prime is a prime number is basically a number times 1 in itself. That's how you know it's prime. So 4 is not prime. If you make a factor tree, it would be 2 times 2. Or really, that's what 2 times 2 is the same thing as 2 squared, right? Now, this one, 2, or really 2 to the 1, is prime. And then 1 is definitely prime, or 1 to the 1 is prime. Okay, so now once you broke it down or put in the most prime form, then you could do you look at your base and if it's repeating, you pick the one with the highest power. So what are our bases? So we have a base of 2 here, but this is a power of 2. This is also a repeating base of 2, but this is a power of 1. And then you have a non-repeating base of 1. So we said that if you have a repeating base, which we do have a repeating base of 2, pick the one with the highest power. So which one do I pick? Do I pick 2 square or 2 to the first? Pick the one with the highest power, so you're going to pick 2 square. And then 1 is a non-repeating base to bring that down. And when you put it all together, 2 squared times 1 is 4. Okay, so that is your LCD. Now go ahead and multiply all three sides by your LCD 4. Okay, so 4 times 5x plus 1. I'm going to kind of briefly do this in my head. What do I see that's repeating the 4s? So the 4s disappear, so you're left with 5x plus 1. Okay, over here you have a minus, so bring down that minus, and then I'm going to put a little bracket, so because I'm going to distribute that. So 4 times this whole thing here, that is a little bit confusing, so write it out. 4 times 2x minus 2. So what I do is I do not FOIL out the 4 and then divide it by 2. What I do is simplify as much as I can. So I can simplify 4 divided by 2. What is 4 divided by 2? 2. So that 2 stays on the numerator, and then you have 2x minus 1. Okay? Or if you want, you can just go ahead and, if it makes, we could do one step further. We could FOIL this out. This would be 2 times 2x is 4x. 2 times negative 1 is negative 2. Close it with a bracket. And then don't forget the further right. What is 4 times x squared? 4x squared. Bingo. Okay. Now let's clean this up and then solve. So over here, I'm going to distribute this. And do you see this minus? It's like an invisible negative 1. So FOIL that out. That's going to be negative 4x. This will be negative times negative is positive 2. And then we haven't done anything with this, so bring that down. And then on the right, it's going to equal to 4x squared. Okay, I think it's wise to move everything to the right because this has the highest power of 2. Now, before I start moving things around, always check if you can collect like terms. So on the left side, what can we collect? Yes, the 5x, negative 4x, which is positive 1x, and then 1 plus 2 is 3. Okay. Now I'm gonna it's just wise to move everything to the right. I mean, technically you can move the 4x to the left, but then you have a negative, and then you gotta get rid of that minus. Just more work, right? So I'm gonna just subtract x and subtract 3. Okay, so you get 0 equals 4x squared minus x minus 3. Okay, now we're gonna factor this. What factoring method shall we use? Can't do simple factoring because the a knows no longer one error. A is 4. So what you're gonna do is try to do and call it the bottoms up. Your teacher might call it something else, but I call it bottoms up because the A value is no longer 1. So first step is rewrite it, although the 4 doesn't exist. So it's going to be x squared minus x. And then the last term is no longer going to be negative 3. It's A times C, or 4 times negative 3, which is negative 12. Okay. Um, this is going to be factored. Let's write out our two parentheses. So it's going to be x times x. And then what two numbers multiply negative 12 and add it gives you negative 1, 4 and 3, right? Times 3, and then we'll do negative 4. So negative 4 times 3 is negative 12. Negative 4 plus 3 is negative 1. Now, remember the 4 from here? What you're going to do is divide the negative 4 by 4 and then 3 by 4. So only this. So you get 0 equals negative 4 divided by 4 is negative 1. That's good. No more fraction. Over here, 3/4 is a fraction, but first check if you can reduce. Can 3/4 be reduced? No. So what you're going to do is put the 4 in front of the x and leave the numerator alone. Okay, and then now you go to solve for it. So I kind of do this in my head. I know it's x equals 1 and x equals -3/4. But if you can't do it in your head, right, um do it algebraically. So we do setting each parentheses to 0, and you're solving for x, right? So you add 1 and over here is from 3. There you go. And I already checked my work for extraneous. Both solution works. Um, yeah, it doesn't make it undefined at all in any way. Okay, let's do letter D. We have to solve for x. So we have 5 over x plus 3 plus 3x over x plus 4 equals 2, or really 2 over 1. As you can see, we have more than two sides, so we got to get rid of the fraction by multiplying both sides, all three sides by the LCD. So this one, we have letters and numbers on the book. So this is, you could think of x plus 3 as one term, or x plus 3 to the power of 1. And then you could also think of x plus 4 as one term, or x plus 4 to the power of 1. So they're all different bases, and they're all in the most primest form, right? X plus 3 can be broken down, x plus 4 can be broken down, and 1 cannot be broken down. So they're premise and they're different bases. So your LCD is basically the mixture of all three. So your LCD is 1 times x plus 3 times x plus 4, right? Or really, it's the same thing as x plus 3 times x plus 4. Okay, so let's multiply all three sides by that. Okay, so let's do for left side. So what do you see that's the same top and bottom, the x plus 3? So you're left with 5 parentheses x plus 4 plus, now do the further right. What do you see that's the same top and bottom? X plus 4. So you're left with 3x and x plus 3. Okay, so you kind of have to kind of do this quickly because, yeah. And then over here, nothing cancels. So just it's 2 times x plus 3 times x plus 4. Okay, you'll do this once you do this one more, it's like basic natural instinct. You'll get it and you'll do it real quickly. So let's see. Now we got to solve. So over here, let's do the right side. Let's see. What I'll do first is foil this out. First foil out the x plus 3 and x plus 4 first, then distribute the two. Okay, so it will be times x will be x squared, x times 4 is 4x, times 3x, and then 3 times 4 is 12. Okay, and then over here, then kind of before I just read this 2, can I collect like terms? Yeah, 4x plus 3x, that's 7x, that's 12. And then distribute this 2, that's 2x squared, 2 times 7 is 14x, and then 2 times 12 is 24. Okay, now let's do the further left. So FOIL this out, this is going to be 5x plus 20 plus 3x times x is 3x squared. 3x times 3 is 9x. Let's see. What can I do? Let's see. I can collect. So we have a 3x squared. I'm collecting like terms. And then I have a 5x and a 9x. That's 11, 12, 13, 14x. And then you have this plus 20. Here, let me put it down here. Now, what do you think I should do? Should I move everything to the right or move everything to the left? I think in this time, I'm going to move everything to the left because you see, if I move this 3x to the right, what's 2 minus 3x? What's 2x squared minus 3x squared? -1x squared. I don't want to deal with that negative because it's more work than I have to do. So let's move everything to the left. So I'm going to subtract 2x squared Subtract 14x, subtract 24. Cancel, cancel, cancel. Okay, so what's 3x squared minus 2x squared? X squared. What's 14x minus 14x? Zeros. What's 20 minus 24? -4. Okay, so what you could do now is you can do two ways. You can just solve for x, or if you see that this is a perfect square, it does factor it out as x plus 2 times x minus 2. You can see that, then you're good. Or you could just do the generic way, add 4 to both sides, right? And then take the square root. Now be careful when you take a square root, you get a positive and a negative, and square root 4 is perfect too. Or you could, if you know you factors out as a perfect square, this is perfectly fine. And when you solve for x, you're going to get +2 and -2, right? That's perfectly fine. And I already tested it. They both work. They're not extraneous in any way. Okay, let's move on. Let's do letter E. Okay, so we have three sides. We have 3 over x plus 1 plus 1 over x times x plus 1. And then you have this 2 over 1. So we have three sides, so we gotta get rid of the denominator multiplying all three sides by LC. So this is a little bit not it's not too bad. You could x plus 1, yeah, this is like really one term if you could think of it as x parentheses x plus 1 to the power 1. Then you have x times x plus 1. This is actually two terms, one, and then this whole thing, and then you have a 1 here. So the good news is they are in the most primest form. It can't be broken down. And we just got to figure out if we have a repeating base. So do we have a repeating base? Yes, we do. Our repeating base is x plus 1, right? This is one term, right? You can think of it as one term. And you have an x plus 1 here, and they're both to the power of 1. So because they are technically repeating base, and they're both to the power of 1, it's just going to be x plus 1 to the power of 1, or x plus 1. And then another base I see is x. This is a non-repeating base, right? This is one term. So it's if it's non-repeating, bring it down. And then you see this base is this one. So bring that down. So really it's just 1 times x, really x. Okay, so that is my LCD. Now you're going to multiply all three sides by that. Now, if for any reason, if it confuses you, when you're multiplying this out, write it out. So let's do the first part. So I'll write it out as x times x plus 1 times 3 over x plus 1. Yeah, so if it, because it's easy to make a mistake, just write it out. But what do you see that's the same top and bottom? The x plus 1. So you're left with 3 and x plus, now do the middle part. Okay, they're practically the same, right? X plus 1, top, and then x over x plus 1. So they disappear. So you're just left with that invisible one, right? Yeah, it doesn't zero it out. You're still left with this one. And then on do the right, nothing cancels. So it's just 2 times x times x plus 1. Okay, so for this out, let me FOIL out the x and x plus 1. So this is going to be x squared plus x times by 2. So that's 2x squared plus 2x. And then on the left, good. It just leaves us 3x. Then I think it's wise to move everything to the right because this is the highest power. I don't want that negative, right? So go ahead and subtract 3x, subtract 1. So you get 0 equals 2x squared. 2x minus 3x is negative 1x minus 1. Okay, now we're going to factor this out. As we can see, the a value is no longer 1, it's 2, so you're going to try bottoms up. So it's going to be, first step is rewrite it as if 2 doesn't exist. So it's going to be x squared minus 1x, and then you're going to multiply 2 by negative 1, which is negative 2. And then factor this out. So it's going to be x, and then blank space. And then what two numbers multiply negative 2 and it gives you negative 1? Definitely 2 and 1. Wait, 2 and 1, and I wanted it. I think I'll use a negative 2, right? Because negative 2 times 1 is negative 2. And then negative 2 plus 1 is negative 1. See how that works? That's how you check it. So negative 2 and positive 1. And then remember the A, remember the original A, this 2 here? We're going to divide that negative 2 by 2 and divide this 1 by 2 only. So you get 0 equals, and then this comes out nicely. Negative 2 divided by 2 is negative 1, no more fraction. That's what we want. And then we have a fraction here, 1 over 2. First, always check if it can be reduced. No, right? 1 over 2 can't be reduced. So what you're going to do is put the 2 in front of the x and leave the numerator alone. When you actually solve for it, you get positive 1 and negative 1/2, right? And I believe, yeah, both works. Yes, definitely. Yeah, you can really check. This is how I kind of I did check on the back of the book, but you got it. If it makes a zero bottomed, like if it makes a denominator zero in any way, that's how you know it's a extraneous. So none of these makes the bottom zero. So that's why they both work, but I did check the work. So I would never want to give the wrong answer. Letter F. So we have three sides. Let's multiply all three sides by the LCD. What is my LCD? So we have an x plus 2. This is like one term. We have an x minus 1, that's one term. And then you have an x plus 1, that's one term. And then you have an x plus 2, that's another term. So the good news is they're all in the most premise form. So let's look at our base x plus 2. Do you see repeating base of x plus 2? Yes, I see it here, and I also see it here. They're both to the power of 1, so it's just going to be x plus 2. What about the base x minus 1? No, I do not see a repeating base of x minus 1, so break that down. And then a repeating base of x plus 1, I don't see that repeating, so bring that down. Okay, so that is my LCD. Do not fill it out, just leave it as it is. So you gotta kind of be good with this and you kind of have to be quick. So let's do the further left side here. So what's this times 3 over x plus 1? So my trick is if you see the same that's top and bottom, which I do see in x plus 2, they're the same. So that disappears, kind of like do it visually in your head. Don't write, so visually exterminate the x plus 2. So you're left with the numerator 3, and then you're also left with, this is an x minus 1. You're left with x in my parentheses, x minus 1, x plus 1, right? Continue. So over here, what do you see that is the same, top and bottom? Yes, the x minus 1. So uh, visually do it in your head. Do not cancel it because you still got to do it on the other side. So don't cancel it. Just visually do it in your head. So the x minus 1 cancels, so you're left with the 1, and then you're left with x plus 1 and x plus 2 equals. And then over here, what do you see that cancels? So this one you can cancel. You can just write it, cancel it with your pencil. x plus 1 cancels, x plus 2 cancels, and then you're left with 1 and x minus 1. Okay, so on the right, 1 times x minus 1 is x minus 1. Um, Over here, you, you could ignore this one because 1 times on anything is just itself. You're going to do some foiling, so x times x is x squared, x times 2 is 2x, 1 times x is x, 1 times 2 is 2. And then over here, I know, like, based on my factoring rules, x minus 1 times x plus 1 is a perfect square. That's basically x squared minus 1. Okay, so if you didn't know that, just FOIL it out and plug the terms, and you'll get this. So you're left with this 3 doesn't go away, so then you're left with x minus 1. Okay, clean this up. So let's FOIL out that 3, so that's 3x squared. 3 times -1 is -3. And plus x squared, and you can collect 2x plus 1x, that's 3x plus 2 equals x minus 1. Now it's wise to get one side 0, so I think because this is the highest power, I think I'll move everything to the left. But before I do that, before I move things around, can I collect like terms on the left side? Yeah, 3x squared and 1x squared simplifies as 4x squared. And then you have this 3x here. And then you have -3 plus 2, which is -1. Right? -3 plus 2 is -1 equals to x minus 1. Okay, now it's wise to move over to the left side. We're going to subtract x, then have 1, have 0, and then this is going to be 4x squared. 3x minus 1x is 2x. -1 times plus 1 it cancels. And then over here, it looks like you could factor out 1x, or really you could for this method, for this factoring method, you're going to factor using greatest GCF. So they both have an x, and you can take out 1x evenly, and then I think you can also take out 2. So this is going to be 2x plus 1, 0, right? So I factor out 2x is my GCF, and then you can't really change this, so that's why I put 2x here, because 2x times 2x is 4x squared, and then I put a 1 here because 2x times 1 is 2x, right? Now, solve. Now, this one's a little bit strange. What you could do is, you see, set each part to 0, so 2x to 0, comma, and then 2x plus 1 equals 0. And then over here, go ahead and solve for x. So this one, you just got to get rid of this 2. So just divide both sides by 2. So this is going to be x equals 0. Now, it's perfectly fine to have a 0 on the top. So if you have a 0 over a number like 0 or 5, it's 0, which is a real number. It's not undefined. And then over here, solve for x, you're going to subtract. Divide this by 2. And you get x equals -1/2. There you go. Okay, example 8. In example 8, A through F, it says solve. So on A, we have 3x, we have this rational function 3x squared plus x minus 10 all over x squared minus 7x plus 6 equals 0. This one's a lot easier than from example 1. Why is this a lot easier? It's because there's only two sides. You have a left and a right. So what you can do is, so if you only have two sides, you can definitely cross multiply. This 0, this does have an invisible 1, and if you cross multiply, what's 1 times this whole thing, it's basically itself, right? 3x squared plus x minus 10. And then over here, what's 0 times this whole thing? 0. Okay, and then what we're going to do is factor this using bottoms up factor. So it's going to be x squared plus x, and then 3 times negative 10 is negative 30. 0. So put an x here, x there, blank space, blank space. What two numbers multiply negative 30 and added gives you a visible one? Definitely 6 and 5. And I'll use negative 5, right? 'Cause 6 times negative 5 is negative 30. And 6 plus negative 5 is positive. So positive 6, negative 5. Okay, and then what you're going to do is, with this a here, you're going to divide the 6 by 3, divide this negative 5 by 3. And then 6 divided by 3 is 2. And then over here, negative 5/3 is a fraction that cannot be reduced. So what you do is put the 3 in front of the x. And yeah. And you actually solve, you get x equals negative 2 and x equals to positive 5/3. Okay, I already checked it, both works. It doesn't make the bottom 0. So yeah, both works. Okay, B. So let's kind of go quickly. There's two sides, left and right, so we can cross multiply. So 1 times this whole thing is basically itself. And then 0 times x, this whole thing is just 0. Okay, factor this out. So it's gonna be x. By two numbers multiply -6 and that gives you 1. Not, I think it's going to be 3 and 2. I'll use -2. So I'll take a 3 and -2. And when you solve for x, you get -3 and +2. Okay, they both work. No, there's no extraneous. Okay, see, two sides so we can cross multiply. So 1 times x squared minus 9 is x squared minus 9. 0 times this whole thing is 0. Then if you really know how your factoring rules, this is a perfect square. So it does factor out as x plus 3 times x minus 3. And we actually solve for it, we get 3 and -3. Uh, yeah, none of this makes the bottom 0, so we're fine. Letter D. Two sides, so this is a divisible one, cross multiply. So 1 times x squared minus 2x minus 8 is basically itself. And then 0 times that is 0, and then factor this out. It's going to be x, x, and then what two numbers multiply -8 and that gives you -2. It's only 4 and 2, and then -4, +2. You solve for it, you get +4 and -2. They both work, doesn't make, yeah, both works. E, there it has only single one. There's only two sides to cross multiply. So 1 times 6x squared plus x minus 2 is basically itself. And then 0 times that is 0. So over here, we got to do bottoms up because the a value is no longer 1. So it's going to be x squared plus x. And then 6 times -2 is -12. So we factor this out. So it'd be x, and then what's in multiply -12 by adding to z1. Definitely 4 and 3, right? And I'll use positive 4 and -3. And then remember the a here. We're going to divide this 4 by 6, divide this -3 by 6. This time it can be reduced, right, a bit. So starting with the 4, 6, 4, 6 can be reduced by 2. So that would be 2 over 3. And then the same thing with the 3, 6. 3, 6 can be reduced by 3. So that would be 1 over 2. Or -1/2. Okay, we can't leave it as a fraction, right? Um, so 2/3, we're gonna put the 3 in front of the x, so that's gonna be 3x plus 2. Same thing with this 1/2, so we're gonna put the 2 in front of the x, that's gonna be 2x minus 1, 0. When you actually solve for x, we're gonna get x equals -2/3, and x equals positive 1/2. So many redundant problems, but that's fine. Or the more the better. So f cross multiply because there's two sides, so 2 times -2x squared plus 9x plus 5 equals to 0 times this whole thing is 0. And what can I do? I'm going to factor using bottoms up, so it's going to be x squared plus 9x, and then 2 times -5 is -10. Factor this out. X, x. Put in multiply -10 and add give you 9, definitely 10 and 1. I'll use positive 10 and -1. And then divide the 10 by 2, divide this -1 by 2. Get 10 divided by 2 is 5. This 1/2 is a fraction that cannot be reduced, so that's going to be 2x minus 1 equals 0. You actually solve for it, you get -5 equal, and then positive 1/2. Okay, example 9. It says find the real A in A through C, find the real solution of the following equation. So this one's a little bit strange. But the thing is, okay, so letter A says we have 8 raised, this is all raised, of x squared plus 2x minus 15 equals to 1. So what you want to do is you want to put it in a common base. Because once you put it in a common base, you can ignore the base, right? You can ignore the base, bring down the power. Right. So this is what you want. So yeah, try to get it, try to get the same base. And then once you have the same base, ignore the base and bring down the power. But so what do we mean by base? So this is a base of 8. This is a base of 1. How on earth will I put in a common base? I think we can use the common base of 8. So if that's true, that means the left is good. But what about the right? How can I rewrite 1 as a base of 8? Well, if you recall anything raised to the 0 power, so for example, 5 raised to the 0 will always be 1. So anything raised to the 0 power will always be 1. So what that means is we can rewrite 1 as 8 to the 0, right? And then on the left, it's 8 to the, it doesn't change, right? Okay. Now, once you have in a common base, ignore the base, bring down the power. And then factor this out, x, x, and then we're two more multiply -15, and that gives you 2. Only 5 and 30. I'll use positive 5. And when I actually solve for it, you get negative and positive 3. So it's okay. B, we have 4 raised to the 2x squared minus 11x plus 15 equals 1. So let's put in a common base of 4. So the left is good. The right, how do I rewrite 1 as a base? How do I rewrite 1 as a base of 4? 4, so it's going to be 4 to the 0, right? 4 to the 0 is the same thing as 1. And then on the left, it's just 2x squared minus 11x plus 15. And then as you can see, the base disappears. So you're left with 2x squared minus 11x plus 15, 0. And then how are we going to solve for x? We're going to factor using bottoms up. So it's going to be x squared minus 11x. And then what's 2 times 15? 30. So what 2 multiply 30 when I gives you -11? Ooh, what is that? Oh, I'll do 6 and 5. And I'll use -6 and -5, right? Because -6 times -5 is positive 30. And then -6 plus -5 is -5. Okay. And then because we're doing bottoms up, so you're going to divide the -6 by your a value 2, divide the -5 by 2. And let's see, simplify -6 over 2 is -3. 5 over 2 is a fraction that cannot be reduced, so you put the 2 in front of the x, and leave the numerator alone. And then when you solve for it, you get x equals 3, x equals 5x. Okay, C, we have a base of 2 and a base of 8. What common base shall I use? I think I could put it in a common base of 2. So how do I rewrite 8 as a base of 2? So 2 to the what power gives you 8? I believe it would be 2. 2/3, right? 2 to the 3, so right? 2 times 2 times 2. Yes. And then here we have x squared plus 4x plus. As you can see, the base disappears, so you're left with x squared minus 4x plus 6, so 3. This time, I do gotta get one side 0, so I'm gonna subtract 3. So you get x squared minus 4x, and then 6 minus 3 is 3. And then factor this out. So you get x, and then 1, 2 multiply 3 now it gives you -4. Definitely 3 and 1, -3. Or we did simple factoring, not bottoms up, so when you actually solve for, you get 3 and positive. Okay. Uh, I think this is the last example. So here it's kind of like a word problem. It has a diagram. So the diagram shows a right angle triangle with sides of 2x centimeters, 2x plus 1 centimeters, and 29 centimeters. So I kind of drew the image already. So imagine you have this right triangle. One leg is 2x plus 1, the other leg is 2x, and then the hypotenuse is 29. What does the direction says? It says find the length of the sides of a triangle. So what do we know about this triangle? You know it is a right triangle. So what we can do is use Pythagorean theorem. Okay, this only works if it's a right triangle. So A and B are legs and C is the hypotenuse. So one of my leg is 2x plus 1 squared. And then my other leg is 2x. And then we got to square that. And then my hypotenuse is 29 squared. Okay. So we're gonna clean this up for get one side zero and for factor it and then solve. So what's 29 squared? 841. What is 2x squared? So you're squaring the 2 and the x. So 2 squared is 4, and then x squared is x squared. This one, be careful. 2x plus 1 all raised to the second power. You just, it's not where you just square the 2x and the 1. It's really the same thing as 2x plus 1 times 2x plus 1. Then you got to FOIL it out. So this is going to be 4x squared, 2x, and then 2x, and then 1, and then you get 4x squared plus 4x plus 1. And then clean this up. 4x squared plus 4x squared is 8x squared. And then this is 4x plus 1 equals 1. Okay, so then I'm going to subtract 841 because we got to solve, right? 0, so this is, yeah, scroll down. So you have 8x squared plus 4x. What's 1 minus 841? Negative 840. Yeah. Now I'm going to solve for x. So the thing is, I could try doing bottoms up, but I know so I could divide every term by 4. Everything's divisible by 4, not 8. So if I divide this by 4, 4, 4, don't forget the 0 as well. You get 2x squared plus x minus 210. Okay, now we may try bottoms up. So it's going to be x squared plus x, and then 2 times negative 210 is negative 420. And then do simple factoring. X, x, and then what you know is multiply negative 420 and that gives you 1. Definitely positive 21 and negative 20. And then divide the divide the 21 by 2, divide the negative 20 by 2. And 21 over 2 is going to be 2x plus 21. And then negative 20 over 2 is negative 10. And you solve for it. I'm going to get two answers. You're going to get x equals 10. X equals negative 21 over 2. Okay, so you have two possible answers. In this word problem, you can only have one x value. And the correct answer will be x equals 10 because you cannot have a negative length, right? Okay. Now, is this our final answer? No, because the direction says find the lengths of the sides of the triangle. We only found x, right? So go ahead and look at 10 in your x or your length. So what was our length? Um, one of my lengths was 2x plus 1, so it would be 2 times 10 plus 1, so that would be 2 times x, 20 plus 1 plus 20. The other one is 2 times 10, which is 20. And then the length, the hypotenuse of that. So our side lengths are going to be 21 centimeters, 20 centimeters, and then the hypotenuse of this one at centimeters. Okay. Okay, that is, yeah. So this is the what did we just learn? We just learned A-level math here, solving quadratic equations by factorization. So yeah, I kind of reviewed your factoring rules, but if you need a refresher, check out the supplementary videos. It explains all the factorization rule. If you need a refresher on LCD, lowest common denominator, there is the video, a supplementary video on LCD. Okay, I am going to stop here.